Hi everyone, today we are going to discuss EMF equation of a transformer. This one is a basic circuit diagram of a transformer here. The center material may be called it as core. This one is core, and two sides of this particular core are surrounded by some windings like this. This one may be called it as N1 is number of turns to the primary side, and 2 is nothing but number of turns to the secondary side. The center thing may be called it as primary, and this one may be called it as secondary. And try to remember one thing. For the side of primary, I may use some notations here as suffix 1. For the part of secondary, I may use some suffix here as 2. Yeah. V1 is nothing but primary voltage. I1 is nothing but primary current. N1 is nothing but primary number of turns in a similar fashion secondary side. And I would like to give some input to the part of primary side. I expect some output here as across loop secondary side. Observe one thing here. When I would like to apply some input voltage of V1 is obviously sinusoidal in nature. Then we can develop some sinusoidal current. When the current travels across this number of turns, we can develop some flux. That flux is also in which nature? Sinusoidal nature. Yeah. When this flux develops, this flux will traveling and cuts the number of turns of primary side. According to the Faraday's law, we can develop some induced EMF. Let it be E1. This one is E1. In a similar fashion, same amount of flux will travel towards the part of other, and it cuts the other side number of turns here, N2, and we can develop some secondary induced EMF E2. E1 stands for self-induced EMF. E2 stands for mutually induced EMF. And without having this flux, we can't develop this mutually induced EMF. And transformer will work on the principle of mutual induction right now, or else Faraday's laws of electromagnetic induction. And don't forget the thing here, the entire whatsoever the VM to I power transfers from one side to the part of other side without change in frequency. Transformer is a static device which transfers some energy or power from one circuit to the part of other circuit without change in frequency, may be called it as transformer basic line. And we can develop some sinusoidal flux now. The center time period here is T for one complete cycle. T is equal to reciprocal of frequency 1 upon F. This one is total time period T. Half of the part may be called as T by T. Another half of the part is also called as T by 4. Across T by 4 value, observe this shaded part, we can develop some maximum flux phi m. This value may be called as phi. Yeah. We can develop some E1, E2 now. I would like to find out what's that induced EMF, and I would like to know the EMF equation of a transformer. Observe this equation. Let N1 stands for number of turns in primary, N2 stands for number of turns in secondary, phi m stands for maximum flux. We all know that V stands for flux density. Flux density is nothing but how much amount of flux will be there across unit area, may be called as flux density B. Can I write phi is equal to VA right now? This side. This one is a formula. Vm stands for maximum flux density. A stands for area. F stands for frequency. Okay. According to the Faraday's laws of electromagnetic induction, we all know that the average induced EMF is equal to rate of change of flux, d phi by dt. I know these two values now, d phi. Previous slide, I know some phi m will occur across the time period of how much? T by 4. Just substitute here. Can you know one more thing? T is equal to 1 upon F now. This one is the thing, right? Yeah, observe this one. Yeah. Phi m divided by 1 upon 4F. Can I write this one like this? 4F phi. This one is nothing but average induced EMF. Yeah. According to the part of form factor for a sinusoidal waveform here is RMS value to average value. It's obviously we know the value for the sinusoidal waveform is 1.1. This one is for the part of sine wave. This value is fixed 1.11. From that, I'd like to find out RMS value. What's RMS value? I know this average and I know form factor value. Now substitute here, try to find out RMS value is equal to 1.11 into 4F5, and I can finalize 4.44 F5. This one is for per turns. If it is for the total number of primary winding turns here as into number of turns. Primary means E1 is equal to 4.44 F5M into N. Can I write this 5M like this? BA. This one is one more. Induced EMF for primary side is this one. Induced EMF for secondary side is nothing but this one. In general, we can write this EMF equation formula as this one. E is equal to 4.44 F5N or else 4.44 Fn Bm into A. And don't forget the units for the induced EMF here as volts. This one is the EMF equation of a transformer. Just try to observe one more numerical so that you have an idea. Yeah. They have given some numerical maybe like this. Observe this one. Maximum flux density in the core of a 250 by 3000. Actually, the transformer values they have given some ratings like this 250 by 3000. In this, what's the 250 and what's the 3000 is nothing but indirectly they have given E1 and E2 values. And try to observe the thing here. From 250, it increases to the level of how much? 3000. And we can observe one thing. It's the type of transformer here as it's a step up transformer. We can indirectly given that information step up transformer. And we know we have given the data E1, E2, frequency, BMS, maximum flux density. EMF per turn they have given like this. That it is, can I write this one? EMF per turn is equal to 8. Can I write E1 and N1? I know the E1 value, substitute there and try to find out N1. In a similar thing, E2 by N2 is equal to how much? 8. Try to find out N2. When I know E1, N1 and N2, can I substitute in this second formula there? E2 is equal to 4.44 F N2 BMA. And in that what's unknown right now, you have to find out area of the core. Finally, we can find something. It's 0.03 meters square. It's the area. These type of numericals come across with the help of some EMF equation. Just try to identify this numerical here. Thank you for watching. If you like my video, please subscribe to my channel. Thank you.